Hi everyone, welcome to Competitive Pharmacy. Today we are dealing with MCQ on pharmaceutical analysis. First question, bathochromic shift is also called as A. Yellow shift, B. Blue shift, C. Red shift, D. Green shift. Correct answer is red shift. Bathochromic shift, position shift of a peak or signal to longer wavelength. Longer wavelength is bathochromic, known as red shift. Bathochromic, longer wavelength, red shift. Hypsochromic to shorter wavelength, and it is known as blue shift. Never forget, bathochromic shift, longer wavelength, red shift. Hypsochromic shift is to the shorter wavelength, also known as blue shift. So, hope you clear this question. Going to question number 2. Which one is not detected by flame photometer? Option A. Question is not detected by flame photometer. Option A, calcium. Option B, sodium. Option C, potassium. Option D, arsenic. Correct answer is D, arsenic. So, flame photometer detect group 1 and 2 elements. Identify group which is not in group 1 and 2 elements. Group 1 elements contain lithium, sodium, potassium, rubidium, cesium, francium. Group 2 elements all beryllium, magnesium, calcium, strontium, barium and radium. So identify which is elements which is not present in 1 and 2. So flame photometer is used to detect the elements which is in group 1 and 2 elements. Moving to next question. Question number 3. Which one is not a carrier gas in gas chromatography? Option A, carbon dioxide. Option B, hydrogen. Option C, helium. Option D, nitrogen. Question is asking not a carrier gas. So option A is the correct answer. Nitrogen, helium, hydrogen. These are carrier gas used in gas chromatography. So because of the safety concerns, hydrogen is not commonly used. Commonly used is helium. Of nitrogen, hydrogen and helium, helium is most commonly used. In addition to its cost, only disadvantage is its cost. Disadvantage is its cost, but it is most widely used one. Helium is most widely used. Hydrogen, due to its safety concern, it is not commonly used. Nitrogen is much less efficient. Helium only disadvantage is its cost. So the carrier gas used in gas chromatographies are hydrogen, helium and nitrogen. Next question. Chopper is used in which instrument? Chopper is used in which instrument? Option A, HPDLC. Option B, HPLC. Option C, single beam photometer. Option D, AAS. Correct answer is option C, single beam photometer. So this chopper direct source radiation. So it is used in spectrophotometer. Chopper is both in single beam or double beam photometer. Chopper is used as a user for chopper. Chopper direct source radiation using a transparent window to pass radiation to the sample and a mirror to reflect radiation to the blank. Chopper's opaque surface serves as a shutter which allows for constant adjustment of spectrophotometer 0% transmittance. So this is used the spectrophotometer. Chopper is used in spectrophotometer, both in single beam or double beam photometer chopper. So question number 5. Detector used in gas chromatography for halogen containing compound specifically. For these options, option A, thermal conductivity detector. Option B, flame ionization detector. Option C, electron capture detector. Option D, photoionization detector. These four options all are detectors used in gas chromatography. But the question is asking detector used in gas chromatography for identify halogen containing compounds. So the correct answer is C. Electron capture detector is the detector used in gas chromatography for specifically identify compound containing halogens. This electron capture detector. So these detector can selectively detect halogens, nitrates and conjugated carbonates. Next is thermal conductivity detector. Thermal conductivity detector. Option A is thermal conductivity detector. That detector is selectivity all compound except for carrier gases. Then flame ionization detector. Compounds with the CH bonds. Compounds with the CH bonds. This gives a poor response for some non-hydrogen containing organics. For example, hexachlorobenzene, in which hydrogen is replaced by 6 hydrogens is replaced by chlorine. So these elements cannot be detected by flame ionization detector. Hexachlorobenzene can be identified by electron capture detector because the selectivity is halogen. Electron capture detector has selectivity in identifying halogens. So this benzene compounds like benzene can be identified by flame ionization detector. When the benzene's hydrogen is replaced by chlorine, it cannot be detected by flame ionization detector. A pure response for some non-hydrogen containing organisms. Hope you clear this sentence. This then is photoionization detector, PID. Selectivity is usually used for aromatics and olefins. Aromatics and olefins is photoionization detectors. Flame photometric detectors selectively for sulfur or phosphorus containing compounds. These are detectors used in gas chromatography. Moving to next question. A non-polar stationary phase used in gas liquid chromatography. Non-polar stationary phase used in gas liquid chromatography. Option A, polydimethyl siloxane. Option B, polyethylene glycol. Option C, polypropylene glycol. Option C, polyvinyl pyrrolidine. The correct answer is option A. Polydimethyl siloxane is a non-polar stationary phase used in gas liquid chromatography. Next is, which of the following would not give rotational spectra? Which of the following would not give rotational spectra? Option A, HCl. Option B, HCF, CH4, methane. Option C, carbon monoxide. Option D, none of these. Correct answer is methane. So, this rotational spectrum is shown by polar molecules like water, nitrous oxide, nitric oxide, NO, N2O. These polar molecules gives rotational spectrum. Homonuclear diatomic molecules like hydrogen or nitrogen and symmetrical linear molecules like carbon dioxide do not give rotational spectrum. This tetrahedral molecule like methane do not possess rotational spectrum. So the correct answer is option B, methane. Methane is a tetrahedral molecule which do not possess rotational spectrum. Uh, this, um, this carbon monoxide and HCl possess rotational spectrum. Then what's advantage? The molecule which do not give rotational spectrum do not responsible to micro. This is the advantage. This is what's the basic for studying this rotational spectrum. The compounds which do not give rotational spectrum do not respond to microwave or Raman spectroscopy. So methane cannot be detected using microwave or Raman spectroscopy. So methane is a tetrahedral molecule which cannot give a rotational spectrum. It cannot be detected to microwave or Raman spectroscopy. Next, this is a simple question. Wavelength of UV region. Option A 200 nanometer to 400 nanometer. Option B 400 to 600. Option C 550 to 200. Option D 400 to 800 nanometer. Correct answer is option A 200 to 400 nanometer, while visible region is 400 to 800 nanometer. The correct order of energy required for different transition. Correct order: N to pi greater than pi to pi greater than N to sigma greater than sigma to sigma. Option B pi to pi, N to pi, N to sigma, sigma to sigma. Option C sigma to sigma, N to sigma, pi to pi, N to pi. Option D N to sigma, N to pi, pi to pi, or sigma to sigma. Correct answer is option A. So the correct sequence is always sigma to sigma transition have greater energy, require greater energy for transition, while N to pi require lesser energy for transition. So this is another question. Sigma to sigma have greater energy of transition, then N to pi have lesser energy of transition. So option A is the correct answer. The band, last question, the band originates due to pi to pi transition of a conjugated system. Option A R band, option B K band, option C B band, option D E band. Correct answer is option B K band. Band due to pi to pi transition of compound with conjugated pi system is K band. So its molar absorptivity is greater than 10,000. It is exhibited by compounds like conjugated diene, triene, polyene, enones, and aromatic rings. Pi to pi transition can be occur in conjugated diene, triene, polyene, enones, and aromatic rings. Next, R band N to pi transition is R band, B band is benzoid band, E band is ethylenic band. So band due to pi transition of a conjugated system is K band. Hope you like this video. If you like this video, please like, share and subscribe. Thank you for watching.